7 classwork curve sketching for trig. So we haven't really dealt with actual functions, and that's not as important for this problem. I mainly chose it just to review how we can do curve sketching. So when we're looking at curve sketching, we talked about justifications yesterday. For curve sketchings, I did just want to review like how we can go from f to f prime. So looking at this, this is the graph of sine, which is our f of x, and I first want us to be able to use that f of x to draw basically what f prime of x is going to look like. You will have 2 questions on your quiz where you have to draw a sketch of the graph. One of them is going to be from f to f prime. The other one will of course be from f prime to f. So looking at this one, this is the graph of sine. Hopefully you know that, but we can graph its derivative. Remember when I graph the derivative, the first thing I kind of do is look where I have horizontal tangent lines. We know that when we have a horizontal tangent line, that means the derivative is equal to 0. So I know that this has a derivative of 0 at all the places where you have a horizontal tangent line. And then I also like dividing it up into sections. So I know that when it changes from increasing to decreasing, different things happen. So remember, as my function is increasing, the derivative is positive. As the function is decreasing, the derivative is negative. So looking at this, when I go to f prime, it's going to be positive, negative, positive, negative, positive. We also know concavity plays a role. When the function is concave down, the derivative is decreasing. When the function is concave up, the function is increasing. So we can also do some divisions if we're looking at where the concavity changes. We do have to kind of eyeball it, but if you look at it, we can kind of see this first part of the function's concave down, and then the second part forms more of a bowl shape. So we can also split it up between concave down and concave up. And so there is a lot going on in this graph, so I just kind of take it slowly when I draw it. Again, those points you put in green are important because that is where the derivative has to be equal to 0. So I'm going to work from left to right, and I'm going to draw it in green so it stands out. So this function starts off increasing and concave down, so my derivative will be positive and decreasing. Then I see the function is decreasing, so I have a negative derivative, and it's still kind of concave down. I'm going to draw it a little bit more smooth. And so I can start drawing in the shape of it. So I have decreasing and positive, decreasing and negative, then it's concave up, so the derivative increases. Then my function is increasing, it's concave up, then concave down. Then decreasing concave down, decreasing concave up, and then increasing concave up. So that green graph does become the first derivative. So we do see that it has a horizontal tangent line when f prime of x is equal to 0. That is a math fact I think is pretty important to understand. The derivative is equal to 0 means we have a horizontal tangent line. I'm not going to really worry about the x-coordinates now, as I want to review that concept. And then this is not really on your quiz, but I like this connection. This is kind of where we're headed after the quiz, when instead of start doing things graphically, we are going to start doing a lot more things algebraically. And one of the things algebraically we can do, instead of saying like, hey, draw in the first derivative, I can give you a function like say the square root of 2 plus x, and I can say, hey, just find the derivative of the square root of 2 plus x. One of the rules that we eventually learn, again, this won't be on your quiz, but I do think it's a neat connection, is that the derivative of sine, if you're looking at this graph that we just did in green, if you think back to pre-calculus, what is that graph we did in green? Cosine. It's the cosine. So literally, again, not on the quiz, will eventually be important, but the derivative of sine is literally the cosine graph. So that's kind of a cool connection we can see by graphing it. So go ahead, just for practice, I'll give you just a little bit because it is very similar to the one we just did. This is the graph of cosine. I'm going to call it G. I want you to use that graph to draw in what G prime is going to look like. So first you would want to, of course, find where you have horizontal tangent lines. Then think about where it's increasing and decreasing. So I shouldn't say the word it. Think about where the graph is increasing or decreasing. Then consider where the graph is concave up and concave down. And then I'll kind of review things you can be working on. To review, things you can review with tomorrow, and then we'll kind of move on from there. So again, if this is the graph of cosine, if I want to graph its derivative, I first put where I see that I have horizontal tangent lines. And we have the horizontal tangent lines when the derivative is equal to 0. So I see that my function is concave down, and it goes from increasing to decreasing. So drawing out the graph, I'm just going to start with this intercept because it's easier. But we have a negative function that's concave down, then it's concave up, then it's increasing, concave up, concave down, and then this shape kind of repeats itself since we know trigs are periodic. That green graph is again G prime of x, so we can still see that the shape does come out pretty nicely. The derivative of cosine also is a graph that you know. So if you remember, the graph of sine is right above it, but it looks like that in its parent function. So the derivative of cosine, again, not important for your quiz, but we will see it later. The graph of cosine is actually the negative graph of sine. And again, those are just some kind of neat connections that we can make between being able to draw these graphs and being able to interpret the derivative. So some things that I want you working on today and also tomorrow. So again, we're not meeting for class. So this is going to be Tuesday homework, and then Wednesday during the day what you're working on. Most important part is your quiz is on Thursday, and that quiz is basically covering topics from homework 1 through homework number 3. Probably most heavy on homework number 3, to be honest, with the curve sketching and the justifications. So things you first want to do is to make sure you complete homeworks numbers 1 through number 3. If you need some extra practice, see the notes tab in OneNote. And I have added 2 extra practices. They are both optional, but they're things that you can look at and check your answer to kind of see how you're understanding these problems. You can also, if you go to the answer key folder, there is last year's quiz in that folder for you to look at. Of course, I want you to ask questions. Office hours are open all day, of course, this afternoon, but also all day tomorrow. I do want you to be able to ask questions and get those questions answered as you have them. Does anyone have any general questions right now? Yes, Lily. Lily, go ahead. Lily, go ahead when you get it working.
Okay, can you hear me now?
Yes, that's working now.
Okay, sorry, my mic wasn't working.
No worries.
So for the optional practice, is there an answer key for that on your
I
Teams?
am going to make the answer key this afternoon.
Okay,
So there will be an answer key, yes, it's just not there yet.
okay, thank you.
You're welcome. So at this point, like if you're good to go, you can leave the meeting. I'll leave it running in case you have any questions you want to ask. But again, tomorrow, I just want you reaching out to me if you have any other questions. That being said, I have nothing else to say. So